All right, getting into lesson 5 of chapter 12. We're looking at compound interest. Here's another one. Again, this is from the formula packet. This whole chapter revolves around these 5 formulas that you see here. So we're now looking at compound interest. Looks complicated, but it's really not. They even tell you within the little paragraph here what those letters represent. So compound interest, if you think about it as investing money, this is dealing with the future value of what you would now have if you invest a certain amount in as the present value. So if you were to take, let's just say $10,000, invest it into a bank, and after a certain amount of time you made $500 of interest, your future value would now be $10,500. And so that would be your future value. Again, this is the initial value, or what you're starting with. R is the percent of interest that you're getting. So if we said 10%, R would be 10. Notice on this that we're going to divide by 100. So for example, when I give you 5%, the common approach is to change 5% to 0.05. You don't have to do that for this because of the 100. That's what the 100 is here for, is to take your decimal and shift it over 2 places for you. So when they tell you 5%, just put your 5 right there, keep the 100, because that 100 is gonna change your 5 into 0.05 for you. So we can just keep that as 5 and then keep the 100. K is your number of compounding periods within 1 year. So for example, if we said it's going to be compounded every month or monthly, well, how many times would that happen within 1 year? So that would be 12 periods of compounding. So K would be 12. If they said it was, if they just say if it's annual, well, if it's annual, that means it's happening once a year. So K is just 1. So again, if they said weekly, right, there's 52 weeks in a year. So K would be 52. N is the number of years. So if we said it's compounding monthly for the next 5 years, right? Well, then we're putting K as 12 because it's monthly, and then N would be 5 because it's happening for 5 years. And so that's what those guys represent. One connection that we're going to make is that this formula is the same as this formula. It's just simply a geometric sequence. That's all it is. Anytime you invest money and you're gaining interest by a percent, that always will fit the geometric model. So if you notice the present value, right, this is what you're starting with. This is your initial amount of money. It's sitting in the same spot as the first term in the sequence. And so it's that initial term, that first term, or the present value. This parentheses that you get here is the R value. When you clean all this up, you're going to get some kind of a decimal like 1.5, 1.25, whatever that decimal is. That's the R value. That's the growth rate that your money is growing at. And then the exponent that you see up here, right? Same with that exponent that we get up here. That deals with the completed periods of time that the money is growing. And so it's really the exact same formula. They just put in some different lettering to help you know what goes where. Anyway, let's get into a couple examples using that formula. So here's the formula up here at the top that we're going to be throwing into. So for example 1, notice these are both just compounding annually. So that's going to mean K is simply 1 because this is happening once per year. So if you invest $2,000 at 6% interest, and if it's compounded annually, so sometimes instead of saying compounded annually, the book will just throw in this. This is the Latin per annum, which is the same thing as saying once per year. So this is just, all this means is that K is 1. That's all that's telling you. It happens once per year. So we want to know how much money am I going to have in 8 years? Well, here's the present value of 2,000. We're putting in the 6 for the interest rate. Remember the 100 is going to take your 6 and convert it to 0.06. So don't do that on your own. The 100 is going to do that for you. We're putting the 1 in for K because it's once per year, and this is happening for 8 years. So 8 goes in for N. So that's our setup. If you're following along with the video, try this in your calculator, because one of the hardest parts about this section seems to be for people just using the calculator and going with this somewhat complicated setup into getting this answer. So this is what you need to be able to come out with in your calculator, so give it a try if you're following the video. Just a reminder, as always, read the directions. If the directions don't tell you how to write your answer, you should be using 3 sig figs. But sometimes the directions will say 2 decimal places, like I did. That's somewhat common whenever you're dealing with money, is to go to 2 decimal places, obviously because of dollars and cents. So just always read the directions. If it doesn't say, you should be using 3 sig figs. Anyway, if you're trying this in your calculator, if it's not working for you, let me tell you what you should be doing to make sure that happens. Start with your parentheses, right? Just like PEMDAS, your calculator works with the PEMDAS order of doing things. So start with parentheses. Within the parentheses, first thing I would do is do 6 divided by 100. Hit enter. Then add 1. Hit enter. Then raise that answer to the 8th power and hit enter. And then multiply by 2,000, and then that should give you this answer. So here's another example. Student borrows $20,000. So here's kind of looking with the same formula, but now it's kind of like sort of the downside of interest. This is you borrowing money instead of you earning money. So, but it still works the same way. So if a student borrows $20,000 for college, 5% interest. So again, here's that phrase, that little PA, this means per annum, so once per year. So that's going to make our K value 1 again for 4 years. So we're looking at, student going to college, they're borrowing $20,000 to go to college. So how much are they really going to owe when they graduate 4 years later? So if we just plug into the formula again, we have the present value. Again, you would have done the 5 over 100 as the setup right here. Up top for this part, again, 4 is the n value. Oftentimes when k is 1, we just leave it out because it's not going to affect your answer that way. If k is 1, if this is happening once per year, you can sort of ignore the k setup within the scenario here. So anyway, here's what we'd have. So 4 years later, we walk out of college. We borrowed 20 grand. We're going to have to pay back $24,310.13. That would be the future value just 4 years later if interest were growing at 5% per year for 4 years. One thing you always want to keep in mind is, again, always read the question carefully, because sometimes they'll spin the question a little bit, and instead of saying, how much will you owe, they could throw in something like, how much interest will you owe? So keep in mind, if I borrowed this much, and this is now what I owe, how much interest do I owe? So the extra $4,310 is the interest that we're paying. And so I would be doing my future value minus the present value in order to get my interest that I'll be paying. So just always read the question carefully. All right, so here's, for these last 2 examples, we're going to look at 2 cases where it's no longer once per year. It's now compounding with something else. So we're looking at the same things from up above, same cases, but now K is no longer 1. So if we're going to invest 2 grand at 6% interest per year, but it's compounding quarterly. So in this case, notice it's the exact same setup from up above. Here's my present value. My rate was 6 over 100. And then we're now putting in the 4 for K because it is quarterly. Remember, K always represents the number of compoundings within 1 year. So if it's quarterly, that would happen 4 times per year. So that means your K value is 4. And then this is going to happen for 8 years. So that's what we put in for N. And so here is the setup. And again, if you're going to try this in your calculator, which I hope you do, because a lot of times people get the setup right and do the calculator wrong. So give this one a try. If you're having a hard time, here's what I would do. I would start out by doing 6 divided by 400, hit enter, add 1, hit enter, raise that answer to the 32nd power, hit enter, and then multiply times 2000. And that should give you your future value. So notice it's just a little bit more than the one we got up above. Not a whole lot, because we're not dealing with a whole lot of money, and we're not dealing with a really big interest rate, but it's still a little more than what we would have had when K was only a 1. So this would be our future value. Here's one more scenario. Again, this is the same value that we did right here in part B, but we're now changing the K value. So for this one, we got the present value of 20 grand. Here's our 5% interest rate over 100. So now this one says compounded monthly, so our K value is now 12, because that would happen 12 times per year for 4 years. So there's our N value, and then if you clean all that up, here's what the future value would be. So again, it's just a little more than the before, when it was only compounding once per year, but it's still more. So the more often you compound this, the bigger the future value would be.